This is Astronomy Daily Live, and it is 2:01 UTC. Somebody's late. Somebody's late. And for some reason, this thing tweeted weird again. So I'm going to have to retweet what I just tweeted, doing it left-handed, which is not my normal hand to be using for these kinds of things. Now I'm going to tweet it. There we go. So, hey, everybody, welcome, welcome. Come on in to the ever growing circle of friends. I have, you know, it's absolutely true that it doesn't really matter what the number of subscribers is. What really matters in sort of the YouTube world and live stream world and any kind of this kind of medium world is the number of views. So the number of views is much more important. However, number of subscribers is an interesting thing to keep track of, and I'm slowly approaching uh, a very pitiful but interesting milestone. So I'm up to 96 subscribers now. Ever getting closer to that 100 subscriber mark, and what what a lot of YouTubers do and live streamers do and all that is they sort of arbitrarily choose these numbers and make them significant, right? And so, 100 subscribers, 1,000 subscribers, 100,000, I mean, 250,000. I mean, as far as I'm concerned, it could be, 1,234 subscribers, right? I mean, it's sort of arbitrary, but um, so I guess what usually happens with these milestones is that a YouTuber will have some kind of a giveaway or some kind of a contest or some kind of a special thing of some sort. Um, so I've decided to do a special thing for my 100th, and the the only the only real rule that I'm going to put into place is that I have to consistently be at 100 or more for about a week. So once I hit the 100 mark, then um, I I will set a little timer for a week, and if at the end of that week I'm still above 100 and have never dipped below 100, um, then I'll do something special on that day. And what I've decided to do in this case is when I have a consistent 100 subscribers or more, what I'm going to do is I'm going to replace that camera with something maybe a little better, maybe just a little bit better, because look, I'm just a poor astronomer, so I can't um, be shelling out you know all these large sums for the greatest camera there is and the greatest computer there is and all that. That's not my game, right? My game is to share the passion, and that um, that I can, if that's strong enough, then I can sort of get away with so-called lower quality in terms of production and all that. Now, but one of my other goals with this live stream is to get better and better and better as time goes by. And one of the definitions of better, at least for me, uh, is to improve the viewing experience. Now, my poor Linux machine is really having problems because I have once again forgotten to I've once again forgotten to to get out of the live stream on that machine. So it is going to have it's going to be running really, really slow here for a little while. I'm going to watch my. Okay, look, it crashed. It crashed. It crashed my browser. So I'm going to quit the browser. I'm going to quit the browser, and that'll take a little while. So hope everybody's doing well. If you're new to this live stream, you can call me Cosmic, and this is just a casual, fun get together of friends every single day, starting at 2 hours UTC and going for about an hour or so. I definitely respect your time. I also know that you have lots of choices when it comes to content um, out there. So, greatly appreciate you either coming in here live right now or later on in the future. Hello, future. Hope everything's well in the future. All right, so I'm going to start my browser up again. And, this live stream is for everyone, right? It's for the um, new people that are just getting into astronomy. It's for the amateurs. It's for the advanced amateurs, and it's for the pros. It's for everyone to come on in and, forget about everything else. TV off, news gone, right? We're thinking about the universe and science and cool things, right? You can sort of think about uncool things for the other, 23 hours of your day, but every single day, just sit back and sort of this is sort of like a virtual porch, right? And we're sitting around, maybe on our lounge chairs, our virtual lounge chairs in a circle, and we're talking astronomy. So cheers. Got the this is the hydrogen hydroxide again, HOH. Very, very calming, very, very nice. So cheers. Now let's see if I can pull that back up. And then I'm going to have to immediately go over to this page where the offending live stream is trying to destroy my Linux machine, and I'm going to very rapidly, as rapidly as I can. Come on, you can do it. I'm going to very rapidly get off of that screen. Okay, so now I should have that, and I see Uncle Bill painting the chat yellow, and I see Tom. Hey, Tom, nice to see you again. Bobby, hey, 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 nice to see you in the chat. Hope everything's well. So yeah, this is for everyone, right? I eventually want to get everybody in here, uh, who wants to and wants to come in and, share the passion. Um, newbies and amateurs are pretty good about sharing the passion. Professionals, they seem to be a little bit more um, uh, um, well, they only really perform at conferences, right? Or if they have some kind of an interview type of a thing. And then, they can be um, uh, very serious and exact about their work and don't want to make any kind of mistakes. They don't want to, uh, they don't want to speculate too much. They never really talk about the really down in the dirt work that goes into whatever they're doing, the monotonous, the meticulous, the mistakes made, the dead ends, the bad data, right? Oh God, can you imagine? I don't think. I mean, this doesn't. I don't think this happens very often, but sometimes, right? You'll go on an observing run, or you'll get um, um, like some HST time, and you start analyzing the data, and you realize that it's like, oh man, this is not right. This is not right. So all those things happen. So um, I would definitely like to get some pros in here, um, other than me, um, talking of just you know talking about what they are working on. Give them the floor. Um, if they want to answer questions and things, that's fine. But otherwise, just sort of a show and tell, what they're working on, what they're doing, whatever, right? So not necessarily like an interview where they're sort of put up on a pedestal as like a high priest, and we ask them things, give us your answers, and they provide the answers, and we're in awe, right? These are people too, and um, so yeah, this live stream is for everyone for sure. And I like to talk. I mean, if you want to call it levels, I like to talk at all levels. So I like to talk about the basic stuff. I like to talk about everything in between, and I like to talk about the high level stuff. Um, as I said, the stuff that sort of flies over my head but isn't completely out of reach. So cheers. So I thought what I would do tonight is maybe something a little bit new that you haven't seen or thought of before. And yeah, I don't know. I don't know if it really has a lot of value or not. I suppose it might. And that is making finder charts from GAIA data, right? We can go to the GAIA archives, data release 2, which just happened a couple of weeks ago. Hey there, Bob Dog. Nice to see you. Nice to see you. Hope everything's well in your neck of the woods, way up there. um, but yeah, you can actually go to the GAIA data release 2 archive, and you can make star charts. Yeah, you certainly can. I'm going to delete that one. I'm going to keep that for now. So let's do that. Let's go over. Um, in fact, let's. You know what? Before I do that, I should do this. All right. This is out of respect. Right. If we're going to be using the GAIA archive in any way, I want to be able to give them the proper credit, right? I'm going to give them the proper credit. So there we go. So there's that. You can look at this later. I'm not going to hold it up there so you can read the whole thing now. This is just giving credit where credit is due, right? These folks and others, right, have done an enormous service. Enormous. Huge. So thank you, everybody at GAIA for letting us access and use this data any way we want, right? The GAIA data are open and free to use, provided that credit is given. So credit has been given. Awesome. Thank you. This is absolutely fantastic. So what I thought I would do is sort of combine a couple of things at the same time. And let's see. Let's go back. I was looking at these asteroidal occultations, right? And to to observe an asteroidal occultation of a star, of course, you need to know where the star is. You have to be able to find it in your telescope, right? And now this isn't the greatest example in the world, but I wanted to, have some kind of a reference here. So um, I'm going to find an asteroidal occultation that maybe is going near me, right? So I'm in southeastern Arizona right now. And yeah, that's going pretty close to me, right? That's at let's see, this is happening on the 12th of June at 10 hours UTC. So 10 hours 5 minutes. So yeah, 10 hours 5, 6, 7 is in there somewhere, 8, 9, 10. This is the terminator here, right? So this is the night side, this is the day side. So if you're over here trying to observe this particular occultation, you're not going to see it because it's right in the middle of the day, right? But for me, 10 hours UTC, 10:05 UTC, I'm 7 hours behind UTC, so that would be at 3:05 UTC. So yeah, I've got at least a good hour and a half here. Um, uh, so yeah, so let's take a look at this a little bit more. So this occultation site already provides finder charts, right? Already does. So sort of what I'm doing is sort of moot in this case. Whoop, but I just wanted to show off the functionality um, of GAIA here a little bit. So this is a 30. I don't know why there's a. I don't know why there's a image here. That's a little weird. That's a little strange. Why is there a? I don't I don't know why exactly there's an image there. Okay, well, whatever. Okay, so let's make a finder chart um, with GAIA, right? And it should look almost the same as that, right? So let's do that. So what I'm going to do is I'm going to. What I need, of course, is the position of the star itself, right? So I need the right ascension and declination, right? So here it is, right ascension, 0 hours, 10 minutes, 28.5 seconds, and a declination of -1 degree, 0 minutes, 50.37 seconds. Okay, so what we're going to do is we're going to go over to the GAIA archive, which is over here, right? I hope you can see that all right. If not, let me, I can post it on the chat. Let me do that. Come on. Post it on the chat. There it is. So let's do a search. And I was already doing a search here, so I sort of have this set up already a little bit. But what I did is I chose equatorial coordinates in a circle, right? And I can give it an RA and a deck. So this was what? It was 0, 0, 10, 28.5. So 0, 10, 28.5. The cool thing is that they if it's not able to understand what you're typing, it'll show everything in red. But if it understands what you're typing, it'll show everything in green, which means it's okay. See, watch when I do, well, no, that's not going to do it. There, see like that? It's like, I don't understand what that deck means, right? So I think it's -1 degree, 0, 50.4, we'll say, 50.4. So 0, 0, 50.4, right? And this chart is a 30 arc minute field of view, right? So from the center to the edge here is 30 arc minutes. So let's make a similarly sized circle, right? So the radius is going to be 15 arc minutes, right? Now the other thing that I want to do in this particular case is I want to limit the magnitude of the stars to, at least in this case, 13, right? So I'm going to look at all the G mean magnitudes that are less than or equal to 13, right? Because, of course, in astronomy, the smaller the number, the brighter the star, right? So let's, well, we can do that later. So let's show our query. Now this is just a basic SQL query. So if you're aware of what that is, you'll know how to read this, right away. And I'm going to change this. I don't think there's going to be that many stars, but let's just change that to 10,000 just for fun. And let's keep everything else. So it's going to throw us a bunch of data, and it's going to do it within a radius of 15 arc minutes, which is 1/4 of a degree, right? That's what this point 25 here is. Here's the RA in degrees. Here's the deck in degrees. And of course, our magnitude is going to be less than 13. So now let's submit this query. I'm going to download it as a CSV file, which is just a comma separated list. So, each column is separated by a comma. So I'm going to submit my query, doink, and job launched. And where is it? Oh, it looks like there's only 8. Only 8? All right, well, let's change this then. Let's change this to 14 and see if there's a few more stars here. 23 stars. Okay. That's, there's not a lot of stars there. I mean, we already know that there aren't a lot of stars here. So, okay, well, let's keep going. So there's 23 of them. All right, so now I'm going to download it. Download it. We're going to save it here. Okay, there it is. So now let's look at it. All right, let's look at this comma separated dude here. And of course, because it's comma separated, we can actually look at it with Excel. So let's do that. But just keep in mind that the actual file, these columns are separated by commas, right? So there's the right ascension, there's declination, there's other things here, like the parallax. Here's the magnitude, brightness, right? And yeah, there's only 24 of them, right? Radial velocities, if they have them, temperatures, if they have them. That's kind of cool. But what we're going to do is we're going to look at the right ascension, which is this column 2, right? 1, 2. The declination, which is column 4, right? 1, 2, 3, 4. And the magnitude, which is column 8, right? So now the plotting program that I use for this is called GNU Plot, and GNU Plot is awesome. It's probably it probably is the greatest plotting program I've ever used. It's extremely versatile. Um, I just like it. I just like it. So I've actually got it started up here, but this is for another data set. So let me, I'm going to, let me get this in a place where I can explain what's going on a little bit. We got to get the name of this thing, 1528079. 1528079 should fill it in. Well, it's not. 1528079. I'm thinking that maybe it doesn't want that. It's not letting me fill in. Let me try 528079. Oh man, I'm gonna have to type that whole thing in. That sucks. I'm not gonna do that. That's just too hard. Now let's try it. There we go. Okay. So what this is saying is plot, do a 2D plot. That's what plot means. And I've sort of told it to just, you know, plot all the x's and all the y's, right? So in this case, the x is going to be the right ascension, the y is going to be declination, and it's going to plot this file, right? Now I've already told it up here, you can sort of see right here, I've already told it that the separator between columns is a comma, right? So, hey there, Tim. No audio here, huh? Huh. No audio? I can hear audio on my end. So, Yeah. Hope everybody hope you can get that fixed. Oh, I should have read the next line anyway. Okay. Yep. Hope everything's good. Um, so yeah. So I've told GNU plot to that each column is separated by a comma, right? And then I'm going to use columns 2 and 4. That is the right ascension and declination. And then I'm going to do this, right? And this is saying to take whatever data value is in column 8, right? Column 8, subtract that from 13, and then multiply by 0.15. And in fact, I'm going to change this to a 14 because that was our limiting magnitude, right? And what that's going to do, this is just a simple mathematical equation that will provide me with a dot size, right? So usually how these things are plotted, and you can sort of see that here, right, is that the bright stars are big dots and the faint stars are small dots, right? And so that's exactly what I want to be able to make as well. So this little equation will do that, right? And GNU plot is awesome, but really the only most important thing to pay attention here is that the color is going to be black, line color of 8, and the point size is going to be variable, right? Which is this. So when I do that, I'll go ahead and do all of that. I'm going to hit enter. Whoop. 28769. Well, let's see. Something crashed. 28. Oh, now what? This thing is not behaving. 75688 0 result. What is wrong with that? No data to plot. Not going to be able to do this. No. Well, all right. Look, I'm going to have to come all the way back in, you stupid thing. Let's see. Where is it? GNU plot. Urgh. So now I've got to. Well, you get to see the whole exhibition here. So I've. This is my only real complaint about GNU plot with Windows, is that you need to go. You got to keep going and going and going and going. Downloads, Astro. Jeez. Okay. So now let's do data file separators, a comma. And so this should work this time. There we go. Now, let's do a couple of things. Let's get rid of this key. Unset key. And I'm going to flip this around because typically RA is increasing to the left, to the east, right? And as you can see in this plot, it's flipped around. So let's just change this a little bit and go. Let's tell GNU plot to go from 2.9 to 2.4. So go backwards like that. All right, and there we go. Let's increase these dot sizes a little bit so we can really see them. Now let's go a little bit more. Like point, let's go 0.5. What does that do? That makes it pretty big. Right, so there's a big bright star here, and then star here, fainter one. So there's sort of a line of stars here, right? So let's see. Now let's go back and look at the actual chart and see if it's there. Ah, it is. There's a line of stars right there. So that's pretty cool. It sort of looks like that star right there is the one that's going to be um, occulted. Sure looks that way. Looks like it is. Yeah. Because, see, you can sort of see there's this bright star. Maybe not. I'm not sure. Because these should be, well, they're not going to be on the same scale. So, yeah, can't be exactly sure. But I'm sort of thinking that this one here is this guy, and that this guy is our target, and that these two up here are probably these two, and this is just outside of the edge. So that's why we're not seeing this big bright star. Um, that's really the only thing that makes a whole lot of sense. Yeah, I think I'm gonna go with that. So, oh, okay, I can make it a little bit bigger there. So, yeah, that's not the most interesting star field that I've ever seen, but Gaia is really cool, right? Because you can actually go into here and let's look at let's go for a name like let's do how about M71, and let's get rid of this condition. Let's just show all of them. Well, let's add another condition. I should have kept that one. Let's look at all of them. The average magnitude less than or equal to, whoops, did I less than or equal to 22? So let's look at all stars that are 22 um, magnitude, um, um, 22 or brighter, right? And it says that M71 is resolved. So now let's show the query. And again, I'm going to change this to like 20,000. I don't know how many it's actually going to be. Let's submit the query and we'll find out. Wow, there's more than 20,000 stars. Okay. Let's go 50. Woo. Can't be that many. It's 30 arc minute field of view. Look at that. It's grinding. Wow, there's more than 50,000 stars. Holy moly. I that might be too rich of a field. Is there more than 100,000? Wow. Okay. So that's 76,671 stars. Wow. Let's um let's go back and narrow this a little bit. Let's go like 5 arc minutes. Whoop. I did that wrong. I want to show my query first. Okay, so now let's do, can't be any more than 10,000 in a 5 arc minute radius, can there? Correct, Tim. Size equals brightness. So the bigger the dot, the brighter the star. That's how all star charts are. So there's more than 10,000. Wow. All right, there's 15,070. So let's grab that, right? So this is a 5 arc minute radius centered on M71. M71, as I recall, is a globular cluster, is a very, very rich globular cluster up in the constellation of Sagitta. Let's make sure that I am looking at the right thing. I just wanted to show you a very, very rich field of stars. And, instead of 24, we've got 15,000. I guess that's enough. Come on, Sinbad. Come on, Sinbad. You can do it. I know you can. You're out there somewhere. I know you're out there somewhere. Oh, is this downloading? Did I tell it to download? I don't remember if I did or not. Did I? I'm gonna do so now. So let's get rid of this one. Oh, okay. Forgot. Come on. Is it really that hard? Okay, we're gonna cancel that. Sorry, I'm gonna delete this because I don't want to have to type these huge names. I'm just being lazy. Okay, so now let's grab it. We'll put it there. So we'll take a couple minutes here. It's okay, so it said it was 941 kilobyte. It looks like it's done. Looks like it's done. So let's pull this up again and try to move that over there. Okay, so now we've got to do 22 minus 8. And we're going to get rid of this. See how it fills in the name for me there? That's exactly what I want. Okay, here's 15,000 stars. You ready? These are going to be a little bit too big. So let's knock that down to 0.15, just for starters. Here we go. Ready? Wow. Haha. That's a couple of stars. Let's go down even smaller. That's a few stars. So yeah, really almost too many to really see. But what we can do, did I do that? Did. Didn't mean to do that. Let's try to get it back up there. I think what I want to try to do is just plot this center area, right? So let's go from like 298,455 to 4 what, 405? Is that right? Am I doing that right? I don't know. So I'm going to go, I want 245 to still be in the center. So if I do 298.455, I've got to think backwards here, right? So minus point, I don't know. 298.455. 298 point. What would that be? Oh man, for some reason my brain is not functioning. So I'm going to pull out my handy dandy calculator and go 298.45 minus 0.005. 298.445. Yeah, okay, that makes sense. 298.445. And for the deck, let's go 1876 to 188. 1876, whoop, 0.76 to 18.8. We're just looking at the center chunk. Whoop, what did I, oh, haha. There we go. So that's a very small region. Whoop, I just did that again. So that's a very smaller region, but you can still see there's a gajillion stars in there. So now let's make the stars a little bit bigger so we can start looking in a little bit closer. And as you can see, GAIA's got the positions of all of these bad boys. Pretty good. Let's expand that a little bit because I'm not seeing sort of the concentration that I was expecting. So let's subtract 0.1 from here and add 0.1 here. And we'll do the same here. Well, let's do 5, 5. Whoops. 4, 5, 5. Oh, yeah, we want to do 3, 5 and 6, 5. Oh, I think I'm getting myself into trouble now. 6, 5. All right, let's let's go back to this. Uh-oh, now I'm in big trouble. Why is it plotting it like that? I must have hit a weird key or something. All right, I'm going to have to get back into it. There it is. I've got to change directories again. This is the tediousness. This is the pain part that most professionals don't talk about, don't show. Doing things over and over and over again. Okay, let's set our data file separator. All right, and we'll get rid of the key at the top because that just makes for more complications. And we're going to look back at this one. Okay. Probably doesn't look much better. Big. Yeah. There's a lot of stars in there, though. For sure. Okay, so let's go. That's 44. Pretty much in the center. All right. Well, what we can do instead is we can go back over to Gaia. So I'm going to delete that one. Oh, where is it? So I'm going to delete that one. And let's go back over to Gaia and say let's look at all the stars that are 17th magnitude or brighter instead. That'll knock down a few of those. Probably get about, oh yeah, only 1,000. Wow. Well, let's go a little bit more then. Let's go like 19th. See how many we get there. So 6,700. 6,700. That's about a third as many. Yeah, let's go with that. Let's see what that looks like. Okay, done. Come on. So now let's take a look here. It's going to be a new data file, of course. There it is. There we go. So, I mean, you can definitely tell that there's a concentration here in the center. And of course, that's because we're centered on M71, which is a very, very rich globular cluster. Did Sinbad ever come up here? Yeah. Sinbad's being a little slow today. Just a wee bit slow. I'll take another swig of hydrogen hydroxide here. Cheers. So M71, looked at that before. So, the Gaia archive is a stellar archive, right? So it's just looking at the stars. So um, if you're wanting to, like see some kind of a galaxy or some kind of nebula with Gaia, you're not going to see it, right? You're not going to see it. You're going to see all the stars in there, but you're not going to see, like the galaxy or the nebula, um, or anything else. Of course, since um, globular clusters are collections of stars that you can actually sort of separate out, then it makes these kinds of plots possible. Um, let's let's see, how can we make that any better? Because it's kind of hard to see that there are bright ones and faint ones. Kind of hard to see. Oh, I think partially because, right, we limited this to 19th magnitude, right, not 22nd. Let's do 19. Okay, that's a little better. So now let's change the size of the, this multiplying part. There we go. Okay. So yeah, you can sort of see that there's a differentiation there between the brighter stars and the fainter stars. I don't really like that though. Let's go right in between, like 0.1. As you can see, one can spend hours doing this. Now, the reason why it's oval shaped and not round shaped is because GNU plot is just trying to fill my screen, right? So it's just the screen that's doing that. Take care, Tim. See you later. Peace. Cheers. Stay well. So yeah, we can see all the all the stars associated with M71 and the surrounding region. So that's pretty cool. Let's dive in here a little bit. I think let's go 28. Let's go 2948 to 298.4. Okay, 298.48. 298.48. 298.4. And let's just do the RA. I think, yeah, it sort of spreads it out. So yeah, that's not the best thing in the world to do. All right, well, forget that. We'll go back to that. Yeah. Anyway, so yeah, this is one way to make finder charts. If you're sort of hard up, not able to um, get charts any other way, you can use GAIA, right? GAIA and a relatively sophisticated plotting program. I guess the only thing that I should really show you is that these things actually are round. So the way to do that is to actually write these out to a file, right? So I can say that my terminal is actually a PNG file, and let's make it like 2000 pixels by 2000 pixels. It's a nice size. And this is actually how I make all the graphics for the videos I make and all the pictures, all the artwork and everything. This is exactly how I do it. So let's do that, and then we can set an output file to be, let's call it just m71.png. So then when I plot this, instead of going to the screen, it's going to go to a file, right? So now we can look here and see that there's a file called m71.png, which we can now open. And maybe, oh, where is it? Oh, where is it? Thought I was being so smart here. Maybe it's still writing it? Not sure what's going on there. Let's go up and back in. There it is. Now let's look at it. That's a little strange. Let's open it with GIMP. 38 kilobytes. That seems a little small. Let's open it with GIMP. Edit with GIMP, I guess. Ka-chunk, ka-chunk, ka-chunk. This poor machine, I'm just making it work so hard. Making it suffer. It has to run GNU plot, and it has to run Chrome, and it has to run the live stream. I'm making it work. Definitely making it work. I really like this picture. I wonder why they chose that particular picture for GIMP. I don't know. Okay, it's kind of hard to see. So let's and this is pretty typical that I need to change the scale around. So let's do like ×1. see what that looks like. Well, I don't know why it's doing that. That's a little weird. Okay, let's try to open this with GIMP again. Take 100,000 years. The GNU image manipulation program, as good as Photoshop, and it's free. In fact, in a lot of ways, it's better than Photoshop. But it's really making my machine work. Poor thing. Let's see if that makes it any better to see. I just wanted to show that it was square. Yeah, or round. See that? Okay, so let's do it one more time. I think 0.1 was too small, 1 was too big. So let's go 0.5, 0.5. Oh, we need to do that. 0.5. Okay, so now let's look at it. And of course, what you see and what I wanted to show you there was that it actually is a round field of view. Which I think you saw. But we'll look at this one more time. Now this is a PNG file that's 2000 by 2000. We can sort of zoom in a little bit and fly around a little bit too. Make that a little smaller. Whoops, didn't mean to do that. Okay, yeah, see, so this is shrunk to 25% of its normal size. So let's go all the way up. There we go. Now we can start seeing members of the cluster itself. Pretty cool. Now you can see, these dots are a little bit big. They start to overlap a little bit. So that's not the best in the world, but given the fact that, we're talking about a globular cluster here, I don't know why I did that, but yeah, that's pretty cool. And you can sort of see, there's some fainter stars, right? So these are all the stars that go down to 19th magnitude. So the smallest little dots here that you see, let's go up to like 200%, right? So these smallest little dots here, which actually turn into little plus signs, right? Those are the the 19th magnitude stars, and everything else looks pretty much brighter than that. But that's pretty cool. That's pretty cool. That's the power of Gaia. Yeah, very, very awesome. Gaia is great. Gaia is going to help us quite a bit. But just to put things a little bit into perspective with Gaia, though, right? Oh, I'm going to exit GIMP and I'm going to exit GNU plot. Give my poor machine a little break here. There we go. Now I'm going to get back over here so I can see what I'm seeing. Um, you know, Gaia has measured the positions of like 1.7 billion stars, which is quite an accomplishment. That's quite. I mean, I'm pretty sure that's the most that's ever been cataloged, and the accuracy and the precision is extremely, extremely good. So we've got a really, really great catalog here. But just to put things in perspective a little bit, that's about 0.3% of all the stars in our galaxy, right? So a third of a percent of all the stars, just in our galaxy, not to mention all the other stars and all the other galaxies, right? So 1.7 billion. Yes, that's a big number. That's a big accomplishment. Um, but relatively speaking, that's nothing. I mean, we're still looking in sort of the neighborhood. Um, I mean, yeah, we're not really seeing anything um, um, too interesting. I mean, in the cases of like um, globular clusters, where we can still see, the individual stars and whatnot, then we're seeing a little bit further out, maybe 10,000 light years or so, um, or maybe 20,000 or 30,000, right? But that's about all we're seeing, right? Most of the other stars in Gaia are, relatively nearby, a few thousand light years, um, and that's it. And that's it. So, yeah, it's a lot of stars, but it's nothing compared to what um, is actually out there. So, I guess part of my point in mentioning that is that we're gonna we're gonna be coming to some supposed conclusions based on this data, and I'm gonna argue that, well, our sample size probably isn't large enough to come to any like firm conclusions saying, this is how it is, because, we've looked at 1.7 billion stars and they all have this kind of a pattern. And therefore, everything else is probably like that too. Well, with 0.3% of a sample size of just our galaxy alone, I don't know if you can come to any kind of firm um, conclusions. Now, is there anything wrong with that? No. No, I think that's what makes things really interesting, is that you know, we're not going to be sure at all. What concerns me is the scientists who are going to say things like, well, we've looked at this large sample and this is what we've observed, so therefore that's how it is. It's like, probably not. Probably not. All right. Well, I'm going to get out of here for today. So hope everybody has a great evening, a great day tomorrow. Um, Made some finder charts today. Gaia covers the entire sky, if I remember right. So yeah, we can make finder charts um, from Gaia if you ever need them. That's a great resource for that. And if you want some help making them, at least the way I did, um, send me an email. I'll give you a hand. cosmiclettuce@gmail.com. All right, I'm going to get out of here for now. Peace, cheers, and all that. And I will see you again tomorrow. Tomorrow. Yeah, yeah. A little less than 23 hours from now. All right. Take care, everybody. And yep, I'll see you on the spin. Bye.